Hello guys, welcome once again to Valeto's Maths Academy. Today we'll be looking at measures of central tendencies, and the formulas we'll be working with today would include the formula for the mean, which is given by x bar, and it's given by the summation of fx all over the summation of x. We're also going to look at the median of grouped and ungrouped data, and then the mode of a grouped and ungrouped data. So if we take our first example, which is from the data below, calculate the range, the mean, the median, and the mode. So this is our data set, and we are told to calculate the range, the mean, the median, and the mode from this data set. Okay, let's delve into it immediately. If we start with the mean, we could say that the mean, which is represented by x bar, is equal to the sum of the data set divided by the total frequency or the total number of elements in the data set. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements in the data set. So the total elements we can represent by n, and this is the same thing. So this is for an ungrouped data. This data now is ungrouped. Okay, the difference between a grouped data and ungrouped data is that a group has more than one element in that group. We'll get there. So for the mean here, the first thing to do is to add the data set, which is 6 plus 8 plus 7 plus 5 plus 9 plus 6 plus 6 plus 7 plus 8 plus 5. Okay, and this will be equal to what? 6 plus 8 is 14, 14 plus 7 is 21, 21 plus 5 is 26, 26 plus 9 is 34, 26 plus 9 is 35, 35 plus 6 is 41, 41 plus 6 is 47, 47 plus 7 is 54, 54 plus 8 is 62, and 62 plus 5 is 67. Okay, so we have the sum, the mean now, which is represented by x bar, is equal to the sum all over the number of elements in the data set, and the sum here is 67 divided by the number of elements in data set is 10, and this is equal to 6.7, and that's our mean. Okay, it's as simple as that. Then we look at the median. The median is simply given by, for an ungrouped data, is given by the middle number. So for the median of this ungrouped data, it will pay us better if we rearrange the data in ascending order, starting from the smallest to the highest number. So if we are to rearrange this data, we're going to have the lowest number here is 5. So we say 5. There's another 5 here. 5, 5, 6, 6, 6, 7, 7. Then we have 8, 8, and then we have 9. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now we've rearranged our data set. Then the median is simply the middle number in the data set. So we could get to the middle number by eliminating from both sides. To do this, we could take off from both sides. We can remove 5 here, remove 9 here, take the next one, take the next one, 6 and 8. We take the next one, 6 and 7. And what we have left is the two middle numbers, 6 and 7. Now take note that we have two numbers in the middle here as the median because the data set is even. Okay, there are 10 elements in this data set, and that makes it even. That is why we have two numbers in the middle. So for every even data set, you're going to have two elements in the middle. But if it's an odd data set, like maybe 9, you're going to have one number in the median, in the middle, and that number is your median. Okay, if it's an odd data set. But when it's an even data set, you're going to have two numbers in the middle. And when you have that, to get the median, you have to find the average of those two numbers, which will now be here. So the median here will be 6 plus 7 divided by 2, which is the same thing as 13 divided by 2. And this is 6.5. So our median here is 6.5. Then the mode is simply the number with the highest occurrence, the highest frequency. And here, which number has the highest frequency? We have 6 occurring 3 times. So 6 is the mode. Okay, it's as simple as that. Here in Paleto's Maths Academy, we try to make mathematics as simple as possible. So we say that the measures of central tendencies is a measure that attempts to describe a whole set of data or population with a single value that reflects its average or center of its distribution. So if you look at the mean, the median, and the mode here, they are all tending towards the middle of this distribution. Okay. That being said, we look at the range. The range is equal to the highest value minus the lowest value. It's as simple as that. And in this case, the highest value here is 9 and the lowest value is 5. So the range is equal to 9 minus 5. And this is equal to 4. All right, that's for the range. Then I'd like to take this a little bit further by talking about what we call the mid-range value. The mid-range value is given by the highest value in the data set minus the lowest value divided by 2, which is the same thing as the average of the range. So this here will now be 9 minus 5 all over 2. And this is the same thing as 4 over 2. And this is the same thing as 2. Okay, so the mid-range value is 2. Then talking about the range, there's also what we call the coefficient of range. The coefficient of range is given by the highest value minus the lowest value divided by the highest value plus the lowest value. And this is the same thing as 9 minus 5 all over 9 plus 5. And this is the same thing as 4 over 14. Am I correct? Okay. And so the coefficient of range is equal to 2 over 7. And 2 over 7 is the same thing as 0.29. Okay. So that's it from As simple as that. That's how you get your mean, median, and mode. Okay, we'll take another example. This is um from this is asking us to calculate the range, the mean, the median, and the mode again. This is a bit different because it's put the data is put on a table. It's quite the same thing because we have the individual numbers here on this column, and then we have the number of times they occur in the distribution. So when you have large numbers like that, it's better to actually put it in a table. We could put this data here in a table also. If you want to put this in a table, it's going to be like this. We call the numbers x, we call their occurrence the frequency. Then you list the numbers. This is 5 from the data set. You have 5, you have 6, you have 7, you have 8, you have 9. Okay, how many times did 5 occur? 2 times. That's 2. How many times did 6 occur? 6 occurred 3 times. How many times did 7 occur? 2 times. How many times did 8 occur? 2 times. How many times did 9 occur? Once. So if you see the total frequency here now will be 2 plus 3, 5. 5 plus 5, 10. You see that? So that's equal to this 10 we have here. So where you have a large number of data, it is better to put it in a frequency table like this, yeah, in a tabular form, so that you can work easily with that. And when you put it in a tabular form like this, then it will pay you better to make use of some important formula. Okay, so now it's in a table like this. It means that 20 is, it's a different equation altogether. It means that 20 is occurring 3 times, 30 is occurring 8 times, 40 is occurring 12 times, 50 is occurring 5 times, and 60 is occurring 2 times. Okay, so when we have our information in a table, we could use a formula for our mean. So we say our mean, which is denoted by x bar, is equal to the summation of fx all over the summation of x, where f is our frequency and x is the individual elements in the data set. So given this formula, then we have to total our frequency first. That's the first thing we do. So if we total our frequency, we're going to have 3 plus 8 is 11. 11 plus 12 is 23. 23 plus 5 is 28. 28 plus 2 is 30. So we have the total frequency to be 30. So we can say that summation of f is equals to 30. Okay, so we have one part of the equation. Then to get the other part, we say f times x. This column is f's, this column is the frequency, and this column is the age. So we multiply both columns to get the value of fx. So 20 times 3 will be 60. 30 times 8, 3 times 8, 24, that's 240. 4 times 12 is 48, that's 480. 5 times 5 is 25, that's 250. And 6 times 2 is 12, that's 120. Okay, so all we need now is to get the total of the f times x. So this sigma means total. Okay, so if we have the total here now, we're going to have 60 plus 240 is 300 plus 480 is 780. 780 plus this is 980, 1030, 1050, 1150. Okay, you're welcome to use calculator if you are comfortable using calculator, but it's, I believe we'll also get the same answer. All right, so based on our formula now, the mean will then be equal to, which is given by x bar, will be equal to sigma fx all over the summation of the frequency. And this is the same thing as 1150 divided by 30. And this will give us 1150 divided by 30. 38.33. 38.33 years. Age is in years, right? So this is now the mean age of this data set. Okay. Then we're asked to look for the median in this data set. So the median here now, to get the median, we have to create a new column called the cumulative frequency column. So we're going to represent that by CF, cumulative frequency. This simply is got by adding the frequency together cumulatively. So here the frequency here, the first one is 3. 3 plus 8 is 11. 11 plus 12 is 23. 23 plus 5 is 28. 28 plus 2 is 30. You must always get the same total as the frequency. So what this frequency, cumulative frequency means is that the first three elements in this data set can be found here. Then the fourth element to the 11th element can be found here. The 12th element to the 23rd element can be found here. The 24th element to the 28th element can be found here. And the 29th element and the 30th element can be found here. That is what the cumulative frequency tells us. It's important you understand this because we're going to be using this a lot to determine our median class, our quartiles and interquartile classes when we get there. All right. Okay. So we come back to where we are. So to know our median, we have to determine the median by dividing the total frequency by 2. So n over 2 is equal to 15. So n here is 30. 30 divided by 2 is 15th element. It means that our median is the 15th element in this data set. So where does the 15th element come? The 15th element, the 11th element stops here. The 15th element comes right, will be found here in this class. So this is our median group. So if this is our median group, we trace it to the age, and it is what? 14. Automatically, it means that our median is equal to what? 14. Okay. Then we look for our mode. Our mode simply means the element that has the highest occurrence in the data set, the highest frequency. So here, if you look at our frequency table here, the highest frequency is 12. And which age has the highest frequency? We have 40. 40 years. 40 years, okay? So it means that our mean is 38.33 years. Our median is 40 years and our mode is 40 years. You see, they are all tending towards the middle of the data set. That is why it's called measures of central tendencies. It's trying to give us a particular number that can represent the entire data. So it's like the average age of the data. There are 30 persons here with different ages ranging from 20 to 60 years, and they want to know the most occurring age, the average age, a single age that represents the population, and that age here is 40. All right. So we're also asked to look for the range, and we know that the range is the same thing as the highest value in the data set minus the lowest value. And in this equation, the highest value is 60 and the lowest value is 20. minus 20, and our range is what? 40. Okay. Then if we look for the mid-range value, our mid-range, like we did the first time, is what? The average of the range, which is the highest value minus the lowest value, divided by 2. And this is the same thing as 60 minus 20 divided by 2. And this is equal to 40 divided by 2 is 20, right? Okay. Then if we look for our coefficient of range, we say that this is given by the highest value minus the lowest value divided by the highest value plus the lowest value. And then this is equal to 60 minus 20 divided by 60 plus 20. And this is equal to 40 over 80. And this is the same thing as what? 1 over 2. And 1 over 2 is the same thing as 0.5. Okay. And that's the coefficient of range. All right. We move on. Here we are in group data. So for group data, we're going to be applying formulas to derive our mean, our median, and our mode. It's basically almost the same thing for the mean. It's just that we make a little modifications. So for our mean, which is given by x bar, we say it is the summation of fx all over the summation of the frequency. Now, but for x now, which is our ages in years, we see that it's in group. In the previous example, we just had one value, 20, 30, 40, just like that. So it was easy to use the value as x. So now that we have multiple values in the group, it means that we have to find a particular value from each group that will represent that group. So we have to find the average per class or group, or we call it the midpoint. So we have to create another column called the midpoint, and that will be our x value. Having our x value now, to get our x value, we say 20 plus 29 divided by 2, which is like the average of each class. We can call this a class, okay? So if we do 20 plus 29, that's equal to 49 divided by 2, that is 24.5. So 24.5 is going to be our working average for the first class. Then for the second class, we do 30 plus 39 divided by 2. So 30 plus 39 is 69 divided by 2 is 34.5. So from this, we can already see a pattern. So we should know that the next class will be 44.5. And the next one will be 54.5. And the next one will be 64.5. Are we together? Okay. So we total our frequency. This is 3 plus 8 is 11. 11 plus 12 is 23. 23 plus 5 is 28. And 28 plus 2 is 13. So the summation of our frequency is equals to 13. So what is left is for us to get our fx now. So we come to our next column. I will create our fx. So this is the value of our f, and this is the value of our x. Our working average for the classes. So that being said, for accuracy and speed, let us employ our calculator. So we say 3 times 24.5. This will give us 73.5. For the next class, the frequency, which is 8 times 34.5. That will give us 276. Then the next one will be 12 times 44.5, and this will give us 534. And the next one will be 5 times 54.5, and that will give us 272.5. And the next one will be 64.5 times 2, and that will give us 129. Okay, then we need the summation of f and x, and that will give us, if we put all that together, we're going to have 73.5 plus 276 plus 534 plus 272.5 plus 129 plus, okay, that's 1,285. Please, if you can tell me if I'm doing the correct thing, if my calculation is correct. So with this, we could get our mean now from the formula to be equal to 1285 divided by 30, and then our mean will be equal to 42.83 years. Okay, all right, so that's our mean. Now, to get our median, we'll need to apply a formula because this is a group data. And the formula, before we come to the formula, let us see where the median class is. To get our median class, how we do that is to first of all get our cumulative frequency, remember, just like on group data. And our cumulative frequency is going to be 3. 3 plus 8 is 11. 11 plus 12 is 23. And 23 plus 5 is 28. 28 plus 2 is 30. It must always be equal to your total frequency. Okay, so from this now, we say n over 2 to know where the median group is, so, or the median class, and this is the 15th element. Okay, so where does the 15th element fall in here? That's this. The 15th element can be found here, so this automatically becomes our median class. So it means that our median can be found between 40 and 49, but we don't actually know the exact value of the median because this is a group containing more than one element. Okay, so now to know the particular, we call this the median class. Okay, to know the particular value, the exact value of the median, we have to apply a formula, and that formula will be the lower class boundary of the median class plus n over 2. N we know is 30. N is the number of elements in the data set minus the cumulative frequency just before the median group or the median class. The cumulative frequency preceding the median group or the median class. This is the median class. The cumulative frequency preceding it, that's this one. Preceding cumulative frequency. We denote that by H. Then we multiply all this by the class size of the median class divided by the frequency of the median class. Okay, so if I'm going to label this, I say L is what? The lower class boundary of the median class. N is 30, we know that already. That's the number of elements in the group. What else don't we know? H here is the cumulative frequency preceding the median class. And is there any other thing we need to know there? F here is the frequency. F is equals to the frequency of the median class. Okay. Having said that, we can then get all the elements that we need. So what do we need here? We know we need the lower class boundary. Now, to get the lower class boundary, we already know this is the median class. To get the lower class boundary, if you observe here, the value here is 39 and the value here is 40. Okay, so 40 is the lower class boundary of the median class, and the higher class boundary of the median class is 49. But take notice that the value here is 39 and the value here is 40. It means that there is a gap. Any age that falls between 39 and 40 is not captured, will not be captured in this data set. For instance, you have 39.2, 39.3, 39.4, where it's not included here. So to ensure that there is no gap, we are going to find the average of this preceding class, the upper boundary of the preceding class plus the lower boundary of the median class, which will be given by 40 plus 39 divided by 2, and that is what? 39.5. Okay, and that is the lower class boundary. So you can also get it by just subtracting 0.5 from 40. Then for the upper class boundary, you can get that by adding 0.5 to the upper class boundary. So why this is to ensure that there's no gap between the classes. Okay. But in a case where the value here is the same as the value here, if you have 40 and you have 40 here, that means there's no gap in the group. Then the lower class boundary will be 40. But since they are different, it means that there's a gap in the group. You have to find the average to close that gap. All right. So, having said that, we can go ahead and work for the median. Is there any other label we do not know? Okay, H is 11 in this case, which is the cumulative frequency preceding the median class. So if we put all that into application, we're going to have L1, which is the lower class boundary, will now be our median will be equal to L1, which is 39.5 plus n over 2. N here is 30 over 2 minus h is the cumulative frequency preceding the median class. Okay, which is 11. What else do we need? Multiplied by the group size, the class size of the median class. We have to calculate that. Now, what is the class size? The class size is given by, I'm putting it here, the class size of the median class is given by the upper boundary minus the lower boundary. Okay, and the upper boundary here is 49.5 minus the lower boundary 39.5. That is the class size. And 49.5 minus 39.5 is equal to 10. Do not make the mistake of doing 49 minus 40. If you do 49 minus 40, you're going to have 9, which will give you a different answer. This is where most students make the mistake. The class size is 10, not 9, okay? Because we are using the class boundaries, the accurate class boundaries. So from our formula now, we multiply it by the class boundary, which is 10. Then we'll divide all this by the frequency of the median class, which is 12. This is an easy formula for you to hold in your heart. Okay? So what is left now is mathematics, is arithmetic. We just need to simplify this. So if we simplify what's in the bracket first, 30 divided by 2 will be 15. 15 minus 11 will be 4. 4 times 10 is 40. 40 now divided by 12 will be 40 divided by 12. That'll be giving us 3.33. So we have that our median will be equal to 39.5 plus 3.33. And then our median will be equal to 42.83 years. I hope that is clear. Okay, please, if you're confused, you could let me know in the comment section, but I think this is pretty clear. What you need is to add more practice, and you'll see that it's very easy. Once you do it over and over again, it will become part of you. Okay, now we need to get our mode. To get our mode, I need to wipe the screen. This lecture will be divided into two because for the sake of time. All right, guys, we'll put an end to this lecture here and we'll continue in the next lecture.